Just answering some of those questions from 5A2 you've requested, and the fractions one. I don't want to answer absolutely all of them. I want to get you started on them. Okay, so I'm not going to do like the whole selection of them. I'll just remind you of what we went over in class so that you can get that confidence back. Or get it in the first place because you haven't experienced maths like this before. That's fine. That's what I'm here to help you with. So if I was answering this one here, I see some brackets, so I need to expand the brackets. 5 times by 2 is going to... I'll expand that bracket. It's going to be 5 times by 2 is 10. 5 times by negative 3x is negative 15x equals... I didn't do anything with the right-hand side. I need to collect like terms. Everyone likes their x's on the left-hand side, so I'm going to remove that negative 6x on the right-hand side. The opposite of taking 6x is adding 6x, so it's going to be 10. Negative 15, add 6x is going to be negative 9x is equal to negative 8. The opposite of this positive 10 here is taking 10. So if I take 10 from both sides, negative 8 take 10 is going to be negative 18. It's going to go further negative. What's the negative 9 doing to x? You're timesing by negative 9, so you're going to divide by negative 9. On both sides, x is going to be negative 18 divided by negative 9 is going to be 2. I'll do the last one. So easy one and a hard one. Expand the brackets. Negative 7 times by 3, x is going to be negative 21x. Negative 7 times by 5 is going to be negative 35 equals x. Negative 2 times by x is going to be negative 2x. Negative 2 times by 4 is going to be negative 8. Let's collect terms. I have two numbers here. I've got 9 take 35. I suck at subtraction, so I'm going to use the calculator. 9 take 35. I'm going to have negative 26 on the left-hand side. I didn't do anything with the negative 21x, so just leave it. I have x take 2x here. On the right-hand side, if I've got 1x take 2x, I'm going to have negative 1x from that, collecting the like terms, and take 8. Let's get all the x's on the left-hand side, so get rid of the negative 1x. The opposite of taking 1x is adding 1x. So if I added 1x to negative 21x, it's going to be negative 20x equals negative 8. What is the opposite of taking 26? Adding 26. If I added 26, so we go 8, make it negative. Negative 8 plus 26 is 18. Opposite of timesing by negative 20, divide by negative 20. X is going to be negative 18 on 20, which can cancel down. 2's into 18 is negative 9 on 2's into 20 is negative 9/10. Equations with fractions. So the first step to look at here is to look, is it just one fraction on either side? This is a single fraction, that is a single fraction. So your shortcut to answering that is to cross multiply. You times the top of the left-hand side with the bottom of the right, and you times the top of the right with the bottom of the left. So the maths that you're going to do is going to be 2x plus 3, and it's getting multiplied by 2, and then you're going to keep the equal sign there, and you're going to have 1 times by 5. This isn't the best way of writing that, because what do you notice about brackets? The number by itself is always on the left-hand side, so a better way to write that is 2 times by 2x plus 3 is 1 times by 5. It doesn't matter that you turn that around, because the order of multiplication doesn't matter. If you don't believe me, I'll show you this. If I do 1 times 2 times 3, what's the answer? The answer is 6. If I do 2 times 1 times 3, what's the answer? 2 times 1 is 2 times 3 is 6. What did I just show you? It doesn't matter if I'm multiplying, it doesn't matter what order the numbers are, you get the same answer. So that's what I showed here. There's a multiplication. So the order doesn't matter. I can chuck the 2 on the end, chuck the 2 at the start. It doesn't actually matter, but this looks nicer for you because you've been taught that from the beginning. So 2 bracket 2x plus 3 equals 1 times 5 is 5. Expand these brackets. 2 times by 2x is 4x. 2 times by 3 is 6, is 5. Now this is what you started off learning with me. Opposite of adding 6 is taking 6. 4x is equal to 5 take 6, negative 1. What's 4 doing to x? Timesing, so the opposite is dividing by 4. Okay? See how you go with that. If you're stuck with the later ones here, then email me again later or ask in class next week. Once again, is it a single fraction on either side? One fraction, 3 over x, one fraction, 1 over 5. So cross multiply. It's going to be 3 times 5 and it's going to be 1 times x. 3 times 5 equals 1 times x. 3 times 5 is 15, 1 times x. X is equal to 15. You got your answer straight away. Might as well do a harder one here. So cross multiplying. But please notice that the top of this fraction is a complicated thing. It's got 2 bits, so you should bracket it. So it's going to be x take 3 multiplied by 5, which is on the bottom on the right, and it's 3 times by x. What's the better way of writing this one? Put the 5 on the front. 5x take 3 equals 3 times is 3x. Expand the brackets. 5 times x is 5x. 5 times negative 3, negative 15, equal to 3x. I'm going to put the x on the right-hand side now. What's the opposite of positive 5x? Take 5x. So if I've removed 5x from the left-hand side, you're going to have negative 15. 3x take 5x is going to be negative 2x. What's negative 2 doing x? Timesing. So you divide by negative 2 on both sides. X is going to be, what's 15 divided by 2? 7.5. Positive 7.5 because it was a negative divided by a negative. So this one here, this example here, I'm hoping should be good enough for you to have a go at these because they're still single fractions, but they're slightly complicated. So make sure you bracket the top and the bottom here, and then you times it out, going cross multiplying. Top of the left times bottom of the right, top of the right times bottom of the left. Give that a go. If you get stuck, let me know again. These are the tough ones here, but it's nothing that I didn't show in the class, so give it a go. I told you that we can't do anything with this because the denominators are all different. This one's a 3, this one's a 6, this one's a 2. The best denominator to use is the product of the denominators. What's the product? Multiplication. So the product of 3, 6, and 2, 3 times 6, 18 times 2, 36. The denominator we want to use is 36. So what do I need to multiply 3 by to make it 36? I need to multiply it by 12. So I'm going to go 2x over 3, and I'm going to multiply it by 12 over 12. Why is that allowed? Because 12 over 12 is just 1. And if I'm timesing anything by 1, it just stays the same. So doing this to the 2x over 3 is going to make it the right denominator that we want. So let's move on to the next term here, which is this, plus, let's group up the x plus 1 over 6. What do I need to times 6 by to make it 36? I need to times it by 6. Equals 7 on 2. What do I need to times 2 by to make it 36? I need to times it by 18 on 18. So now 2x times 12 is 24x. 3 times 12 is 36 plus, let's rewrite this with the 6 on the other side because the order of multiplication doesn't matter. 6 lots of x plus 1 over 36 equals 7 times 18. I don't know my 18 times tables. 18 times 7, 126 over 36. The denominators are all the same now, so we can ignore them. They're all going to cancel out. So my algebra now is 24, is just the top lines. 24x plus 6 bracket x plus 1 equals 126. Expand those brackets, it's 6x plus 6. I didn't do anything with the 24x equals 126. Collect these like terms, 24x's and 6x's is 30x's plus 6 equals 126. How do I get rid of the plus 6? Take 6 from both sides. It's going to be 120. 30 is multiplying, sorry, x is being multiplied by 30. So you divide by 30 on both sides. They're going to cancel. X is going to be 120 divided by 34. This last one here is one of the trickier ones, but it's similar to those. I want to give you an opportunity to do one of the super hard ones without me stepping all the way through it. So I'll ask you, are these denominators all the same? No, the denominators here are x take 2, and x bracket x take 2. What did we do last time? We found the product, okay? But what do you notice? If I timesed x and x take 2, what's the answer going to be? X times by x take 2 in brackets looks like this, x bracket x take 2, which is the denominator of the third one already. We don't need to multiply this by anything because it's already in the denominator that these are going to turn into if we multiply them. Okay, so if I wanted to give you a little setup, I need to paste a little rectangle for working out here. This is what we're trying to work out, 6 over x. What do I need to times this x by to make it look like x bracket x take 2? I need to times it by x take 2 on x take 2. Why? Because x take 2 divided by itself is going to give you 1. Move on to the next factor, 4 over x take 2. What do I need to times x take 2 by to make it look like this, x bracket x take 2? I need to times it by x on x. And the last one, it's already the denominator that we want. It already is x over x bracket x take 2, so we're not touching the last one. So if you proceed, 6 times by x take 2 is going to look like that on the top, and then the denominator is going to be x bracket x take 2. The top of this next one, 4 times by x is going to be 4x on x bracket x take 2 equals, and we didn't touch the last one, and its denominator was already x bracket x take 2. Are the denominators the same now? Yes. So now you have a bit of algebra that looks quite similar to what we've done. Oh, the highlighter's not. Why is the highlighter not working? This looks like something that we've done before, the top line there. That's a shame that the highlighter's not working. Why? Maybe it's a PDF. Oh, there. Why is it? Oh, it's because I've made the white rectangle. All right. I don't want to finish that off. I've pushed you down the road for that. See if you can finish that off from this point. And I might help you with the other ones. Okay. Hopefully that helps you out. I'll see you in the next video.